Well, first I'd like to say, we had the same debate when we were talking about what happened with COVID in the airlines, and we're about to issue a report showing that the investment the government made and made quickly actually is going to pay the government back into the investment. So it was a COVID pandemic, and we had to make decisions about whether to keep a workforce and keep them running, and the U.S. approach to that worked. So here, it's kind of, all of you have touched on this in so many different ways. It is about future investment. That's why this hearing is about the advancement of next generation chips. It is about how does the United States keep its leadership in that. And as you all have noted, we've gone from 36% down to 12%, and the question remains, if we do nothing right now, where are we going to go? So I definitely believe in ecosystems. I believe in the manufacturing supply chain that exists for automotives and for aviation, and I certainly want a manufacturing supply chain and ecosystem to exist on something as essential as chip technology, given the information age. It is, you could say it's the ultimate supply chain, if you will. So the question on this graph here, you can see that the amount of U.S. leadership has continued to fall off as we go to those next generation chips. So this isn't just about how many chips you can produce or whether you can produce chips that were the last generation of chips. This is about producing the next generation of chips with the higher intelligence. That's why, I don't know, Mr. Gelsing, I really liked your detailed testimony about all the advancements that Intel is making, the ribbon FET, the Power Via, the EUV, that's a partnership with a European company, ASML, and obviously Mr. Archer is talking about this as well as it relates to plasma. So this really envisioned, you are kind of like the ultimate story of translational science that we're trying to capture in the R&D bill. We're trying to tell our friends here and people in America that we've done a lot of basic research, we've done a lot of advanced research, but China is spending 80% of their dollars on commercialization. So this is about whether we take the next generation of technology and get it deployed faster and remain on the leading edge. And if we don't, then all that manufacturing is going to go somewhere else, not in the United States. And as we can see from what's just happened, I think Americans woke up and understand intuitively what supply chain is all about now. They know exactly what that means. That means they don't get their product. And now if you tell them that the ultimate product of the supply chain, chips, is all now leading edge in a country, in the island of Taiwan, then you basically are sitting here with a big vulnerability of the United States. And I think the last events of several weeks make that even more poignant. So the question is, what is it that we need to keep doing to keep on the leading edge of this technology? So you gave us this, you gave us all these advancements in these chips, which I wish I could drill down on. But basically, you're talking about IP boost, you're talking about better connectivity, you're talking about more translation of. So from the first chip to today, what is the difference as far as what it means? And maybe I'll ask Mr. Feit what it means to him when it comes to the product that he's trying to deliver today. But could you just give us, Mr. Gelsing or Mr. Murray, what kind of, what are we talking about as far as advancements of chip capability? I mean, I believe in Moore's Law, but help people understand here. The first chip did X, and now here's where we are with this level of advancement.
Yeah, thank you. And, on my lapel here, I was the chief architect and designer of the 8486 chip for Intel, introduced in 1989. And this chip had 1.2 million transistors on it. Right, the most advanced server chip that I just put into your hands here as samples is on Intel 7, which is, your chart is now out of date. We're in production on our 7 nanometer products. This is 25 billion transistors, right? Which, just is mind-boggling, the progress that's been made. And as we think about application usages like in autonomous vehicles, the most advanced AI applications, right, vision detection and being predictive management of driving, the most advanced mRNA sequencing capabilities, speech recognition capabilities, the AI applications across numerous industries, 5 and 6G connectivity. All of these depend on the most advanced technologies available. They need the highest performance computing at the lowest power capabilities to process these most advanced algorithms. We predict that by the end of the decade, we will have our first trillion transistor chip. Right? And those kind of capabilities are for many of the immersive experiences of the future that will define the future competitiveness of industries globally.
Mr. Fight, what do you need, Mr. Fight, from them? What do you need them to keep doing that as it relates to next generation technology for your trucks and efficiencies?
Sure. I think Mr. Gelsinger spoke well on the high technology end of some of the needs we have for vehicles that are fully electric or zero emissions, using hydrogen fuel cells, or in autonomy where visual graphics are so important and machine learning is so important. We need high-end chips. But we also, as the industry, the agricultural, the automotive, the truck, many other industries, need some kind of, I'll call it more standard chips that keep affordability at the right level and performance at the right level to make all the cars, trucks, tractors that we need in this country. And so they shouldn't be left behind in that thinking. It can't have a life cycle of 2 to 3 years. Otherwise, the cost of products will go up incredibly if we're forced to redesign cars, trucks, and tractors, medical equipment that quickly. So it's kind of a both and, Senator Cantwell.
Yeah.
Thank you so much. My time has expired, but I